Hello, welcome to another lesson of MathHands.com. Today we're learning about trig. Today's section is incredibly important. Today we're doing these things called reference triangles, and the idea is absolutely crucial. This is the foundation. This is for the definition of the trig function. So it is absolutely crucial to get this idea. I can break it down in a couple of steps. First part of the idea is this. It's very easy. Every single angle, I don't mean some angles, I mean every single angle has what we call a reference triangle. That's the lesson for today. Every single angle has what we call a reference triangle, and the entire purpose of the lesson today is to learn how to get this reference triangle. If we can do that, then we will be incredibly powerful and ready for the next section. Okay, so let me tell you the recipe for a reference triangle. Here's the recipe. You have to start off with, of course, an angle. Suppose you started with some angle 30 degrees. Well, yeah, let's make it 30 degrees. According to our statement here, every angle has a reference triangle, so 30 degrees must have a reference triangle. Here's how you cook up a reference triangle. You start off always on the XY plane. This is the x-axis, this is the y-axis. And it is customary to start off always, well, it's not customary, it's by definition, reference triangle starts off on the positive x-axis. That means this part of the x-axis. This would be the negative side of the x-axis. This is the positive side of the x-axis. This is the negative part of the y-axis. This is the positive. Reference angles always begin to be measured from the positive x-axis, meaning from here. And they always start off with a segment of any length you want. For example, I can make it length 2. And what you do is you spin it this way, counterclockwise for positive angles, and you would do clockwise for negative angles. So this one would be 30 degrees. This is 90, so that would be way too much. Halfway would be 45, would be somewhere around there. That's 30 degrees. And we make this length any size that you want. For example, it could be length 2. And this is called the angle in standard precision. To make a triangle, keep in mind, what's the name of the game today? This is the name of the game. Every angle has a reference triangle. So I'm trying to draw the reference triangle for 30 degrees. You start on the positive x-axis, you go counterclockwise for positive angles, and you pick a segment of any length, and then once you're done drawing the segment, you keep one of the ends on the origin, and the other end you go from it and you draw a perpendicular towards the x-axis. Here's one choice, here's the other choice. That would be towards the y. We never ever do that. We always go towards the x-axis. So from here, draw a perpendicular to the x-axis so that this is perpendicular, and that right there is a reference triangle for 30 degrees. And also you should be able to label the sides. Label the sides means figure out how big they are. That is the whole purpose of the last week and a half has been, the last 4 or 5 lessons have been to learn 30-60 triangles, 45-45 triangles, almost triangles. The reason we learned all those is precisely so we could come to this point and have no problems drawing the reference triangle. If this is 30 degrees, you should have no problems figuring out the length of these sides. Across from 30, you always find the small one, which is half the hypotenuse. 2, half of that. Use your calculator if you have to. 2 divided by 2. Go ahead, use your calculator. That would be 1. And then, I'm just kidding about that. And then across from 60, you take the small one, you multiply by the square root of 3. So there it is. And you label the sides this way. To the right, that's positive. So the x, this part right here is positive. And then up is positive. And the hypotenuse is always positive. And there it is. That's the reference triangle. Okay? If you think that was easy, well, it was. Maybe we can try it on another example. Okay, again, let's try another example. Again, what's the name of the game today? Every angle has a reference triangle. Okay? This is a hint, subliminal hint. What's the lesson for today? Every angle has a reference triangle. So let's say 120 degrees. Every angle has a reference triangle, so this one must have a reference triangle. Start on the XY plane. This is the positive side. You go, your segment can be any length you want. Positive angles always go counterclockwise. So far you've gone 90 degrees. You got to go 120, so you go 30 more. That would be right around here. That right there, that's 120 degrees. 120 degrees. And you make this length, any length you want. I'll make it length 2. And then from the end, you draw perpendicular to the x-axis. Let me think. Would that be towards the x-axis like that, or would that be towards the x-axis like that? Well, only like this. This is not towards the x-axis. This is the y-axis. That's not the way to do it. Always towards the x-axis. Draw perpendicular to the x-axis. That's the reference triangle. By the way, just out of curiosity, what angle would that be in here? If you've gone 120, how much more have you got to go to get to 180? You got 120. How much more have you got to go? Use your calculator. This is 180. Take away 120. That would be 60 degrees. This other one here would be 30 degrees because they have to add up to 180. And now we use our excellent 30-60 skills. 30-60 triangle skills. We know. We own it. You should own it. You should prove it. You should be very comfortable with 30-60 triangles. Alright, across from 30, you always find the smallest side, which is always half the hypotenuse. So this one's got to be 1. The other one's always the small one times the square root of 3. And then we label the sides and include the signs. If you're going left, that's going negative. If you go up, that's positive. So there you go. That's the sides being labeled, including the sign. Okay? That was so fun. We're going to try it again. Let's try some negative angles. Suppose we try negative 150 degrees. How would you do that? Are you scared of doing that? Let me think. We cannot be scared. This is the x, this is the y. You always start on the positive x-axis. Positive x-axis. For negative angles, you go clockwise. So you go. That's 90 degrees. You got to go some more. That's 180. Whoops, that's too much. We don't want to go 180. We only want to go 150. Let's start over. 90 degrees. How much more have you got to go? 60 degrees. So it's right around here. This is total of negative 150 degrees. The question, and then from there you draw perpendicular to the x-axis, always to the x-axis. You make this any length you want. I'll make it length 2. And then you finish the rest of the story. Think about it. To label the sides, you're going to have to know about these angles. If this is 150, how much more have you got to go to get to 180? This has to be 30 degrees inside here. And that makes this one 60 degrees. And across from 30, you always find half the hypotenuse. The other one's always square root of 3. Left is always negative. Down is always negative. And there it is. Again, the hypotenuse we always keep positive by definition. The only things that are positive or negative is if you go left. Going left is negative. Going down is negative. If you go to the right, that's positive. If you go up, that's positive. And there it is. That's the reference triangle for negative 150 degrees. Let's do it again. This time we can do, I don't know, something crazy like 300 degrees. See if you're afraid of that. What are we going to do with 300 degrees? Again, here's this subliminal hint. Every angle has a reference triangle, so this one must have a reference triangle. How do we draw it? By definition, a reference triangle is given by the triangle obtained starting on the positive x-axis. This is a positive angle, so you got to go counterclockwise. That's 180. How much more have you got to go? 90 more. That's 270. Back all the way 360. Whoops, we went too much. We went all the way 360. Whoops, we went too much again. we gotta go only 300, so maybe this time we'll do it right. 300, 360, that's too much. Come back 60. There it is, all the way to 300 degrees, 60 short of a full revolution. Draw a perpendicular, make this any length you want. We'll make it length 2. Finish labeling it across from 30. Across from 30, you always find half the hypotenuse, that's 1. Across from 60 would be the square root of 3. Okay, now to the right is positive, down is negative, so this one must be negative. Just like that. That's the reference triangle for 360 degrees. No, I'm sorry. That's the reference triangle for 300 degrees. Okay, maybe we can try a couple more. This time, let's try it for 420 degrees. For 420 degrees, let me see. Start here, you go all the way around, that's 360. How much more have we got to go after you've gone 360? Well, you got to go 60 more, so that would be right around there. And you could sometimes we represent it this way. By representing a full revolution, then up there some more. That's 420 degrees. You drop a perpendicular to the x-axis. This one is 60 degrees. This one is 30 degrees. You make this any length you want. 2 across from 30, you find the smaller one. Across from 60, you find the square root of 3 times the small one. You label the sides, the signs. To the right is positive. Up is positive. You're good to go. 420 degrees. Okay, this is called the reference triangle. Absolutely crucial for the rest of what we're going to be doing. Let's try some of these other odd ones. Let me see. Let's try 225 degrees. For 225 degrees, you'd go 180, 45 more. This would be 225 degrees. The inside angle here would be 45 degrees. After the 180 mark, draw a perpendicular always to the x-axis. Make this any length you want. I'll make this length square root of 2. Why? Because I can. You can make this any length you want. Well, there's more to it. Of course, you know that on a 45-45 triangle, the other legs are the hypotenuse divided by the square root of 2. So it's very convenient to make this the square root of 2, because to get one of the legs, you could divide this by square root of 2 and you get 1. To get the other one, you divide by square root of 2 and you get 1. Of course, that's a nice choice for the 45-45 reference triangles. Now you include the signs. If from the origin, you go left, that's negative, and then you go down, that's negative. That's it. That's your reference triangle for 225 degrees. There's plenty more where that came from. Let's do some other strange things here. How about the reference triangle for 0 degrees? Whoa. Chew on that. For 0 degrees, let me think. You start on the positive x-axis and you go counterclockwise. So, there. Make this any length you want to there. Draw a perpendicular there. It's not much of a triangle, is it? Well, this is one of those. That was the whole point of us learning those new types of triangles, which we called almost triangles. In fact, 0, if it's too troublesome, maybe you could pick something that's really close to 0. Maybe like 0.000000001 degrees, just like that. And you know, the angle here is pretty close to 0 degrees. You make the hypotenuse any length you want, so we can make it length 2. That would make that side pretty close to 0 units in length, and this one must be pretty close to 2. Okay, this is how you would handle 0 degrees, and it turns out all of these will have a similar triangle like that. The ones that end up on one of the axes, on the y-axis, for example, if you do 90 degrees, if you do 180, if you do 270, or if you do negative 90 or negative 180, all of these will have a similar story. Let's try 90 degrees. It turns out that 90 is troublesome, so maybe we could do 89.999999999. So, and then from there you draw perpendicular not to the Y. Never, ever, ever, ever to the Y. Don't do that. Always to the x-axis. By definition, always to the x-axis. So you make this length any length you want. So make this 2. This right here is approximately 90 degrees. This one right here is approximately 0 degrees. That means this side right here is approximately 0 units. And this side over here is approximately 2 units. Okay? If that was too fast, just rewind it, watch it again. That's the beautiful thing about this format. But I hope that you spent some time doing the homework on these ones. They should come easy. We could try again. Let's do 180 degrees. 180 may be a little bit troublesome, so maybe do 179.9999999. This is 179.9999999 degrees. And so that you draw perpendicular to the x-axis, you make this any length you want, 2, 2, 0. Left is negative, up is positive. There's your reference triangle for 180 degrees. Okay? This section is absolutely crucial if you really want to understand the trig functions. Okay, I think that's all for now. Your job now is to draw a whole bunch of reference triangles and realize that every single angle has a reference triangle. Always, 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 you start on the positive x-axis. You start here, and you go counterclockwise for positive angles, this way for negative angles. Draw a perpendicular, always, always, always to the x-axis. Label the sides, include signs, and you should be good to go. I think that's all we got for now. We'll see you guys here next time.